Go ahead, Marty.
All right. Thank you very much. And thanks for inviting me to give this talk. In a lot
Can
of
I
ways.
just interrupt for a second, Marty, and
Yes.
ask you to switch displays? We're in the presenter mode.
Oh, I thought it just switched for me. I didn't know it switched for you. There we go. That's better, right?
Yep. Thanks.
Okay. All right, cool. You guys are just over there. All right. So yeah, this is in a lot of ways kind of a retrospective over the last many years of the program, and then also kind of a look to the future. So yep, I'll talk a little bit about what is this RU program, and something about the students who have been in it, and where it's going next, and what's next for me. So RU programs in general are funded by the NSF to provide experience for undergrads, and then they're aimed primarily at students without access to research, and that certainly is what we've tried to do. Targeted underrepresented groups. All the NSF topic areas have RU programs. Ours is under the Atmospheric and Geospace Sciences Division. But I think they also kind of share funds, so some of our money comes from astronomy and so on. So in addition to the money that the NSF has provided, I also want to gratefully acknowledge all the support that we've gotten over the years from many other sources. HAO has sponsored 2 students every year since the beginning, I think. Source has sponsored 3 students per year up until the end of the Source mission. So we won't have that moving forward. This Colorado-Wyoming Alliance for Minority Participation has also provided some support. I got an extra supplemental grant for magnetospheric students 1 year. The Emirates Mars mission has sent students, and also mentors often will have a little bit of funding available for students, and I want to gratefully acknowledge all of that support. So let me just give a kind of a one-slide history of the program. So it started in 2007 when we decided to create the Boulder Solar Alliance. Emily Kobabe Aman ran this program, although Dan Baker has been the nominal PI for the entire history. So he's been a wise guidance from the top. So we started out with requesting 8 weeks of support for 8 students. And Emily then a few years after that left LASP, and I took over the program in 2010. There I am as Mojo Jojo. So, and then we've been able to renew the grant several times. In 2012, we got another 5 years. In 2017, we changed the parameters a little bit to make it 10 weeks and 12 students, and also included some travel to AGU, and welcomed into the Alliance the National Solar Observatory. Rumors are that the reason they only gave us 3 years is they wanted to make sure that the marriage with the NSO was going to be a smooth one, and I think it has been. And in 2020, we were renewed again for another 5 years. So we are currently in the 2nd year of that 5-year grant. And I just wanted to mention the institutes in Boulder have had student programs before this REU, and in particular the one for HAO was kind of merged into this, and I in fact am an alumni of that program. I was here in the summer of 1986 and worked on a project with Art Richmond, who I believe has retired. So what do we do in this program? The primary goal is to introduce students to authentic research in solar and space physics. We include a week-long introduction to the field. We provide professional development. I'll talk about that a lot more. And the students get experience, presenting their results as well as doing the work. So the first week we set aside for what we used to call a summer school, and then we decided to call it boot camp, mostly because Claire Raftery said we should call this boot camp. So the goal of this week is to provide an overview of the study of solar and space physics. We provide some lectures, and then we do several activities that kind of build the group of students into a cohort so they can, you know, support each other and look forward to being colleagues for long periods. So they do kind of a group project, which primarily is about collaboration and also is about not having necessarily a defined, you know, follow this script and then you're done. So an open-ended project. We also include some social activities with mentors so that people get to relate to their science mentors outside of just the office. We provide an introduction to scientific programming. And another important thing is this, we bring back some recent alumni of the program, which in a normal year meant that they were going to grad school in Boulder or working in or near Boulder. You know, there was some good and bad with the pandemic because we could invite people from farther away. But so generally, these students who have been in the shoes of the incoming interns, you know, within the last few years, they're sort of near peers. So, you know, it's one thing for an old guy like me to say, oh, you're going to get so much out of this program. Whereas it means a little bit more if a student who was in it just a few years ago, you know, can talk about really what the experience was like. So the boot camp lectures, you know, we have a couple on solar physics, you know, depending on the year, there may be 2 or more, you know, the solar interior, solar atmosphere, solar wind, talks on the magnetosphere, the Earth's atmosphere, space weather, and essentially how all of these things are an interconnected system for the, you know, Sun-Earth connection. So we try and hit it all, right? And since we normally do this the week of Memorial Day, we only get 4 days. So it's a lot to pack into that first week. When I talked about projects that people have done, you know, long ago, they would spend just a few hours kind of thinking about like, all right, if you wanted to make an instrument that, you know, measured this property, you know, how would you do that? What kind of detectors would you need? Would it be grating, you know, some sort of camera? Does it have to be in orbit, and so on? All those sort of high-level systems engineering sort of things. We've also done an inquiry where you just give the students some information and they create questions and try and answer those questions. We launched a balloon instrument. This was really cool, right? We bought some little kits and they made little temperature and pressure sensors and a balloon, and some group had to make the data to decode the telemetry, and some others had to try and figure out how to track the balloons and so on. It was an awesome project. Didn't work. Yeah, lost telemetry after like 10 seconds. But, you know, it was a great learning experience. Another year, we used the solar monitors that Stanford puts out to try and detect some solar activity. You know, did more balloons. Last year we did, or the year before, heliostat and a pinhole camera. They programmed an Arduino to track the sun and so on. Oh, I'm sorry. This is actually the 2019 project. I'm highlighting these photos because CU sent their professional photographer because they wanted to do a story on one of the former alumni who was also then helping to run the program that year. So we had better than average photos. That was the heliostat. And then, of course, I think people have fond memories of the barbecue that we hold at the end of the year. Started out at Emily's house, and then when I took over, it was at my house. So students get a chance to kind of unwind, chat with each other a bit more, and enjoy some food. The professional development, which, you know, is kind of an important piece that they don't necessarily get from just taking classes, right? So we start off with you know, anti-discrimination and harassment curriculum. We talk about ethics, Imposter syndrome is an important thing to make sure that the students are aware of. The students also will get chances to practice giving talks from the 30-second elevator pitch on up through a 20-minute talk and making a poster. We also have a career panel where we find people who are in science jobs but are not necessarily what you would think of as a typical scientist or a college professor or whatever, that just to open the students' eyes to the fact that they may want to be a scientist, and then if the sort of research that they do during the summer isn't quite to their taste, that there are a lot of other jobs that they could do which are still in science but are slightly different. We also, of course, teach them about what are the elements that they need to have to apply to a grad school, right? And and then of course how to give a talk, how to make a poster, how to do your CV, how to write a manuscript, all the perils of navigating the peer review process, and of course tours of all the great facilities in the Boulder Solar Alliance. Down here, I don't know if you can see my cursor or not, but yeah, obviously one of the students thought that this was a serious activity. I don't know if she hadn't met me before or something. Of course, and we also try and build the community among the students by doing things outside of the research environment. Going on hikes, viewing the wild animal sanctuary or anything like that. So we try and do some of that every year. The stargazing in the Rocky Mountain National Park is very popular. One of the former head of the mission ops and data systems at LASP was one of the organizers of the amateur Northern Colorado amateurs, and they have star parties every other week in Rocky Mountain National Park. So that's a great place to go. And then of course, they do their research. I'm not going to talk about anybody's individual research projects. This is about the program, right, and the people, not necessarily about the science. So they do get to give final presentations. Bonus points if you can identify which room we use for the final presentations there. I see that I accidentally chose almost all from that same 3131 at NCAR. We also have them present posters, right? So that they get a taste of what it's like to give a talk, but also, early career scientists often will be giving poster presentations at AGU or wherever. And I think that's a really rewarding thing for them to have exposure to. Over the years, the venue for the posters has changed from $2.99 in LSTB over to the lobby of SPSC, but I think everybody has gotten a lot out of that. And of course, recently we've had funding to send students to AGU to present their work, and I think that has been extremely rewarding as well. I also get the benefit of running into the alumni of the program from the last many years. So down in the lower left, you probably recognize Graham Kerr, and then some other students that I've had in recent years, and they've and so yeah, I think they like catching up with their old RU chums. I even get messages from people who are like, oh, look who I ran into on the campus of UCLA. Turns out we're both going to grad school here. They get to see each other and automatically have a colleague from their past. So and the moose and cat is just a metaphoric representation. That moose was never a participant. Don't try and tell the NSF that they funded a stipend for a moose. One of the students one year denied that any moose lived in Colorado. So that was a running joke the rest of the summer. So there's the moose with the cat. I guess that's me. Okay, so one of the reasons that I was invited to give this talk was to talk a little bit about diversity and inclusion in sciences, and I think that our program has definitely had that as a huge goal. And so here are some statistics. So the number of applicants rose over the years. It did kind of peak in 2018, although that number may be slightly inflated by including some of the international candidates. I think most of the other ones are only the U.S. candidates. So the number of students we've accepted over the years, has gone up by a factor of 2, but the number of applicants has gone up by more than a factor of 10. So that's great that we have become a very popular program, but it does mean that we have become more and more selective, right? A smaller fraction of the acceptances, that a smaller number of the applicants get accepted every year. So why, you may think like, well, what happened there? Why do we have that huge peak, right? So, and I credit this peak in applications to these amazing recruitment videos that Claire made. And in the test, you could hear the audio. Hopefully you still can.
University of Colorado, but a lot of you will end up working in different science institutes across the city. Me, I personally work at NOAA, and there's 2 of us that actually work in this building. But I know there's other places like the High Altitude Observatory. They got about 4 people. I think that's really the strong point of this program. And I think it's nice that you have one big larger group, but you also have a smaller group where it'll just be you and a couple other people. I just really feel grateful that I'm able to work here and work with these researchers at the Space Earth Prediction Center. This is the only thing of its kind in the country.
Yeah, definitely the benefits to having everyone at these different institutions is sort of we've been able to tour a bunch of them and sort of see what's been going on in like the different branches of something that's all sort of under the big umbrella of space and solar science.
So what I was most surprised by in my work here was how much autonomy I was given. Both of my mentors were gone for a whole week, and they left me in charge of the entire spacecraft, which was really cool and something that I didn't expect to be so much in control of what I was doing and have such a big part in the research that I was.
It's fun because, for instance, in the event we're studying, I found the actual event, and he started looking at it. We were able to bounce our ideas off of one another, so that way we're actually going to publish a paper, and a lot of my ideas are actually going to be in the paper.
The part of this program that I really enjoyed is having a lot of freedom and the community that I'm in at school from a smaller institute, so there aren't as many physics majors as a bigger institute. So being in this area where there are a lot of organizations that have a lot of professionals, you can really see what I can do in the field and the opportunities that are waiting for me.
I applied to this program because I know that I can benefit from being in a research institute where everyone around me is doing science.
So coming to this RU, I was really intimidated that I wouldn't maybe be able to do the work or I wasn't competent. But what I found here is a really supportive group of people that has helped me through this summer. And it's been so positive for me.
I didn't have to go to Tom or any of the other mixed people. If I had questions with IDL or anything, I could go to basically anybody in the whole people area. And nobody was judgmental, nobody was harsh, because it was all very much a helpful environment from people who are mentoring you, even if they weren't technically your mentors.
All right, and I'll show one more short video.
It gives me a sense of feeling in the work field, being with professionals alone. It really gives me a sense of like actually having a job and working and giving me a real insight of what it's going to be like in my future.
Coming into this, I didn't know anything about space physics, and this is a good opportunity to find out what that is without committing the whole career to it.
If you've never done this before, if you're worried that you don't know what research is about, but you know that you're interested in working in space science or in solar physics, this was a great way to get started. Almost every single one of us came in and was like, I'm really nervous for this RU because I have no prior experience. And they're going to ask me to do coding, and I don't know coding. Or they're going to ask me physics questions, and I'm a math major, and I've never taken a physics class before.
I almost didn't apply to this program because I'm majoring in applied mathematics. I really didn't know that I would fit in. I was shocked with the amount of information we were given in the first week. I was able to get started with my research with like a firm understanding of solar and space physics.
First week was summer school. Basically gathered all of the RU students in the room, and we were given overviews of different parts of just the Earth and the Sun and Mars, and we had several speakers come in that were scientists at different institutions that are in Boulder, and they gave us an overview so that we could understand what was going on.
During that week, we learned a lot about solar flares, coronal mass ejections. So being on the same boat that week was definitely helpful.
So I have never had any experience with solar or space physics before this program, but once I got here, it felt very familiar because it just drew on all these other things I'd already learned in my physics and other astronomy classes.
I think I was the most surprised by how prepared I felt to do this kind of work, because it gave me a lot of confidence knowing that the school that I went to has prepared me for this type of work, and having this experience really contributed to that.
All right, so yes, I think putting those videos on the web and on the YouTube definitely led to many more people being aware of the program. So, so who have we accepted over the years? Here's kind of some charts showing the breakdown. So this is the gender balance, and you know, the Excel had one choice for colors, and PowerPoint chose a different set. So I put the symbols so you could really tell. And as a hint for the part 2 of the talk, so there's a majority of females in the program. I think that's a great part of what we've achieved. In terms of ethnicity, it's still overwhelmingly white students, but with a smattering of other ethnicities, which compared to the rest of this field, it's actually much better than the field at large. We also tried to do an important balance of where the students are, right? So it's true that the majority were at LASP, but with HAO and NOAA, both SWPC and NCEI, and then some smaller institutes all can contribute by providing mentors. So that's been great over the years. So what happened in 2020, right? In January, students are applying, we're picking students, and then there start to be hints that, oh, there's this pandemic, maybe we should not actually be near each other. So we had to make the decision to make the program virtual. I think that many RU programs just canceled entirely, or said, well, we'll defer the people we accepted this year to next year. So there's, many fewer programs out there. And so we're proud that we were able to have a program and to make it work pretty well. So all of the mentors need to take great credit. They all said, yeah, let's do a virtual program. That's way better than just canceling. The NSF said, hey, whatever you need to make it happen, you can have complete budget flexibility. If your student needs computer, get them a computer. If they need better internet, get them internet. If they need housing, right, pay them what you would have paid to host Twin Boulder, right? Even many students would have apartments. They still would have leases that they need to pay and so on. So wherever they were going to need to live somewhere. We also provided a training for all the mentors on best practices in remote mentoring. I think that was very rewarding in the evaluation at the end of the year. In particular, the younger mentors, or less experienced, I guess I shouldn't be ageist, the rookie mentors found that extremely helpful to talk about, like how do you build a mentoring relationship in a virtual environment. So what did we have to change, right? everything, right? So in the boot camp week, you know, you do a couple of icebreaker activities at the beginning, but since the only time you see those other people are they're a little square on your screen, icebreaker and, you know, getting to know each other activities became more important. We also suddenly had students in several different time zones. You know, in a simple world, they would only be from Eastern time zone to Pacific time zone. Well, we had actually included a student who was living in Ireland at the time and had to remain there. So yeah, we had quite a bit of the globe involved. And later in the summer, a student in Dubai also joined, who was in a very different time zone. So one of the ways that you accommodate that is, you know, you don't have this long day where you say, okay, now this is everybody's lunch, right? Because that could be dinner time for some and breakfast for others. So having several long breaks is a strategy for an all-day meeting. We had to adapt the group project to become a virtual project along the lines of what Nick Gross had done for the Heliophysics Summer School that year. So we helped, we gave him a chance to develop that as a virtual project. For the professional development, we did, you know, the standard, you know, ethics and publishing and so on. But we also added in several more opportunities to talk with alumni at different stages of their career. So we had, you know, some who were professors and others who were researchers. And there's, you know, one who was working designing the Messenger app for Facebook and so on. We also arranged several talks with scientists in different fields. We had the planetary science and stellar atmospheres and so on. We also were able to lure a couple of people who are on review committees for graduate schools, and or we also had the woman running the research program at Max Planck to talk about what sorts of skills are you know people are looking for in accepting students into graduate programs. So I think that was very valuable. We also added another thing called Science Friday. So that was an opportunity to bring in speakers to give a more in-depth talk on topics that weren't covered in the very first week. And the career panel, right? We didn't have to just take people from Boulder. We could take people from all over. So, you know, we had a data journalist and someone who worked at another software company. I'm trying to remember, it was like TensorFlow or something, some AI amazing thing for Google. So all of the students who were doing AI projects that summer definitely wanted to get her email address so they could get internships there. So how did we do? So this is from the evaluation at the end of the program. We have an external evaluator who queries the students on all the different aspects. So the two charts that I'll show from the 70-page report were, you know, how did they do with the professional development sessions that we had. So you know, talking about stellar atmospheres, talking about grad school, talking about to different RU alumni and so on. So overall, everybody said that was either extremely valuable or somewhat valuable. Hardly anybody gave it a score lower than that. You know, the other chart is a rating of how the research project went. And so 90% strongly agreed that they, if they had the chance, would work with that team again, right? 10% said that they agree. So like 100% either agreed or strongly agreed that they would want to work with their mentor again. And I think this really highlights the quality of the mentors in this program. You know, I've always said, like, the program works well because the mentors are so awesome. And speaking of awesome, we I will, spoiler alert from the second half, right? I will be leaving Boulder and turning the program over to the able hands of a team. So Claire from the National Solar Observatory has been helping with the program many years. So she's the most experienced member. And Yunchen Zhu from LASP also helped out last year. And then the new, Willow there on the right, she also helped run the program in 2019. And Wendy and Amy, also at LASP, have been mentors in the program before, but haven't run it before. But so they're the new team. So in 2021, we are going to go virtual again. So we have many lessons learned from last year. Certainly there's all the disadvantages of being a virtual program, that you don't get to really interact in person, but there are some advantages, right? You're no longer as limited geographically for speakers and so on. So we'll take advantage of what we can and deal with the obstacles as they come. So far, we have almost as many applicants this year as last year. And I think if you were thinking that you wanted to be a mentor this year, you might be able to still sneak in your application. You'd have to make sure that you're in the good graces of the new team. But that's kind of where that part is. So that's where the program is going. So where am I going? As was hinted before with the lions and so on, I will be leaving Boulder and moving to Hermanus, South Africa. So so I still will get mountains, right? I love mountains. I've lived in Colorado almost all my life, so I've been around mountains. So now I get mountains and apparently the ocean. And as we were chatting about at the beginning, everybody who has visited there says it's amazingly beautiful. I unfortunately have not actually been there yet. So where will I be? So the South African version of NASA, the South African National Space Agency, or SANSA, has a space weather warning center in Hermanus. The photo in the lower right kind of shows that big green square. That's the campus of the facility in Hermanus. So I think they've grabbed enough that they have some room to grow. I don't know that it will eventually be as big as Goddard or something like that, but they're planning ahead. So this is the only space weather warning center in Africa, and it's designed to provide space weather information to other African countries as well. It's being expanded. There's a new research or a space infrastructure hub grant from the federal government to expand many programs. And one of them is that currently this Space Weather Warning Center is not a 24/7 really operational center, but that's in the near future, probably while I'm there. So what am I going to be doing? So there's this South African Research Chair Initiative where they want to improve topics that are not currently studied in the region. So they bring in an international candidate to essentially create a program. So there's a lot there from the webpage. The too long didn't read is that I'm going to get to go mentor students and collaborate with all my friends from around the world. So I am going to be the research chair in space weather and then in parentheses solar physics. So right now, there's essentially no solar physics community in South Africa. There's the space weather practitioners, and there's upper atmosphere research and so on, but nobody doing actively doing solar physics. So in South Africa, obviously sees that this could be a long-term economic benefit to promote the study of the sun within South Africa. And so SANSA proposed to their federal government to create this research chair position, and I was lucky enough to be chosen. How did I stumble onto this? Right. Here's the walk down Marty's little memory lane here. Last summer, summer of 2019. Where did 2020 go? So I knew that the source mission would be coming to a close. And at the time, we thought that the funding would kind of wrap up around September of 2020. You know, I wasn't really sure which project was going to provide me with the majority of my funding. I have several grants, and you know, there's other projects that I'm part of. But then, you know, I saw a job ad for somewhere at NOAA, and I thought, like, oh, you know, that could be a good transition, you know. So I updated my CV and applied for the job. They didn't pick me. And then about a month later, I saw on, like, you know, one of the mailing lists this ad for the job in South Africa. And I thought, well, you know, I've already got my CV ready. I'll send it in, you know. Maybe in the, you know, I'll get lucky and get in, you know, on the short list and get invited to give a talk. That'd be cool. So I had an interview in February of 2020, and you know, found out a lot more about the job, and thought, like, wow, this actually sounds like exactly what I love doing. Right? It's mentoring students, increasing the diversity of the workforce, and, you know, helping people get a leg up into a professional career, which is what I've been doing in everything in the first half of the talk. Right, so in May, I found out I was on the short list, which meant that I got to fill out the bureaucratic form to their National Research Foundation. That took a long time. It was like 60 pages. And then I didn't really hear anything during the summer. So we're running the RU program, and, you know, in the back of my mind, I'm like, well, you know, there could be this job, but probably not. And the PI thesis 2 invited me to be the instrument scientist lead on the spectral irradiance monitor. And so I figured, okay, well, I guess that's an opportunity that's passed, and I'll stay at LASP and be very happy. And then they wrote back at the end of the summer and said, hey, we would like to have another interview with you, and we would like you to give a virtual talk. And so at the end of September, I gave a talk, and they're like, okay, well, we'll let you know by middle of October. It took them a little bit longer than that, but yeah, at the beginning of November, they said, okay, here's a contract. We'd like you to decide within a few days, and start April 1st. So I said yes, and then panic. Okay, so what will I be doing? I'll have an army of students, several undergrads every year, a couple of master's students every year. I think just one this first year, but and then also advising PhD level students. And I have a postdoc who actually is going to start the same day that I am. I did meet him earlier this week. It looks like he's a great guy. Since there are no programs in solar physics, I get to travel to universities throughout South Africa, talk to the students, tell them about all the great things that solar physics can do for them, and all the great things that they can do for solar physics. And also, they chose me because I have friends around the world, so I can build collaborations, international collaborations with South Africa. I've already talked to many of the people in Boulder about interactions having to do with the instruments or data analysis or whatever. I will also be doing public outreach events, I think. In that first interview, when they said, what do you think about public outreach? And I'm like, oh yeah, it's very important, you know, and I give tours of LASP to the public, and they all perked up. So I'm thinking that I'm going to be giving tours of the SANSA facility. And then of course, traveling to conferences, right? So I hope to see everybody at conferences around the world through the years. With this Space Infrastructure Hub grant, they plan on participating in a satellite. I'm not sure that they quite understand how big of an undertaking getting a whole satellite up with instruments on it is, but we talked a little bit about ideas for instruments and how people in Boulder could collaborate on those instruments. They've also decided that they would like to put a ground-based solar telescope on their facility, partly for outreach. But if it can collect useful data, they're happy with that too. Oh yeah, and I guess I'm supposed to continue doing research. Okay, we'll squeeze that in somewhere. Okay, so yes, help. All my friends at HAO and the rest of the Boulder Solar Alliance are going to be my primary source. I mean, I have European connections as well, but basically all of you are now going to be collaborating with South Africa. I know HAO has great student visitor programs. I'll be looking for co-mentors for grad student projects, and I will be asking people for guidance from afar. So we go from this launch to recovering the spacecraft. All right, so the next, I guess I still have 10 minutes or so. There's continuing the walk down memory lane. I have some photos from every year, and I don't know. I don't know if this is being recorded or not, but certainly I can post the slides, and everyone who's been a mentor over the year can kind of look back. It's like, oh yeah, I remember that. So as I said, we started in 2007 with a moderate size group. This was back in the LSTB before we moved. The students went out for Harry Potter night and so on. The following year, we had about the same number of students. The gentleman holding up his poster at the bottom left there, that's Brian Kirby, who is the lead systems engineer on the Emirates Mars mission. So yeah, I think many of the students in this program have gone on to very successful careers. There's Emily. I'm not sure why there was a Halloween thing in May, but there it is. In 2009, there's not quite so many pictures. I wasn't running the program there. So yeah, there's the group of students. It was actually the smallest cohort we had. Tom Woods and I mentored a student, so I have the photo of us there. The following year is when I took over, so there's lots more pictures now. The Boulder Solar Alliance, usually in the summer, will get together at the Southern Sun and invite all the students and let them have beverages like the water that Rachel is drinking there. And the picture in the center is the two Rachels, grad student at the time, Rachel Hawk, and Rachel Vermiglio, who is a professor in the Colorado Community College Association. We had the posters, and we always do this thing at the end of the first week, drawing the sun and the earth and all the connections between them, and then take a picture in front of them. So we got that. We have some other activities, going out on a hike, having some food, doing some work. Uh-oh, my cat is stepping on my mouse. Stop that. Okay, yes, on to 2011. Another happy cohort. Some of those are grad students who were here at CU. We had and there's Amy as the mentoring. That might have been her first time mentoring. We had great interactions the whole summer. On to 2012. Again, students work hard in these projects and create long-lasting friendships. So I think that's one of the additional benefits there of the being colleagues in the same field. At the beginning of the summer, we say, like the people in the room are, currently, your fellow RU students, but when you stay in the field, they're going to become your professional colleagues over the next several decades. So be nice, right? And then on, we went out to the observatory one night. That's the red lights there. 2014 was another great year there. I guess they're all great years, right? And look how happy everyone is at the end of the first week. I still have a few more minutes here. I don't know what to say about those other than, you know, this was a great experience for all the students. I know that I think everybody in these photos has gone on to grad school. Sarah Swenson did an internship at NIST in Boulder and is now going to CU. The woman there on the left just graduated with her PhD from the University of Hawaii, and I'm still friends with many of these students. You know, that's also been very rewarding to watch their careers. I think everybody has that experience of your mentees going on to great careers is very exciting. Pictured here is Erin Wood on the right hand side. Let's see if I can remember left from right. She was helped run the program for many years before leaving LASP in 2016. And there we are launching the balloon, and there's Frank looking studious. I think I saw that he joined the meeting, so hopefully he's still here. And you know, at the end of the summer, students love to take little photos of, like, we were at the NSO and here, and then down in the lower left there's some heckler asking the student about his poster. I don't know if Scott showed up today or not. But anyway, so we are moving on towards the current time here. Here's 2018 and 2019. Many of the students in this photo were in the videos. That was the year we made the videos. So last year, we couldn't have one of those group photos like we had. But again, Claire used her wizardry skills to essentially Photoshop us all together as if we had been able to stand there, and she adjusted the lighting and switched us around. One of the secrets is that somebody is wearing somebody else's shoes because they were in a photo without shoes, and they needed to have them for this photo. So that's what we would have looked like had we all been together. This is what we really looked like for most of the summer, right? We all just were little squares on the screen. All right, so I'm almost out of time. I do want to also give thanks to Michael Thompson, who was an extremely strong supporter of the program as HAO director. Even if he didn't have students in a given year, he would come to the end of the week barbecue just to talk to the students. And so there he is one year with the 5 students who were at HAO. I think he was a great mentor to them all. So he will be sorely missed. All right, well, I'm kind of out of time. So the summary is that the RU program is in great hands with the new team, a good mix of experienced and rookies who will lead the program forward. I have no doubt that they will do a great job. So yes, I'm a little bit nervous since I've never been there and not quite sure what all I'm getting into. I've had a taste of the bureaucratic side of it so far, but I think everybody has said what wonderful people are in South Africa, and I'm really looking forward to the ability to benefit a lot of students to get them a foot into the world of professional science and solar physics in particular. All right, so thank you very much. And I will stop sharing. Or at least I'll try and stop sharing.
Thank you for the nice talk, and sounds like an exciting adventure to come. If anyone has questions or comments, you can either type them into the chat and we can read them out, or feel free to speak up.
I've got a question for Marty.
Uh-huh.
So we have such a critical mass of solar scientists in the Boulder area, but not that many positions for solar scientists outside in the larger world. So I think a lot of transferable skills in our internships that span disciplines and scientific endeavors. Can you comment at all about how you have dealt with that? I mean, you've touched hundreds of students, and some just careers in solar physics, but many have gone on to other careers. How do you encourage or otherwise convince students that what they're learning is transferable and useful?
Right. So I always say at the end of the summer, when some students are like, oh, this is totally my passion, I am looking forward to going to grad school. And then there are other students who say, I am really glad that I had this experience because this is not at all what I was expecting. I do not want to continue this as my career. I consider both of those results as a win, right? This student found out in 10 weeks that they want to have a totally different career. They have time to make a correction. They, don't end up going to grad school for a couple of years and then wishing that they had never done that. So that's all positive. And as one of the students in the video mentioned, she was an applied mathematics major and wasn't really sure if this program was for her. She did great work that summer, doing some modeling of solar eruptions, and now is a data scientist in Denver. And realized no, I don't want to get a PhD. I just want to get a master's and switch career lanes. So I think part of the career panel definitely targets the you can have a science job and it's it could be operating a telescope, it could be measuring solar maps, it could be anything, and these are all great science jobs. Making planetarium shows, we always have a friend doing that. So I agree that the science topic that people do their projects on doesn't necessarily limit them to what they can do as a career. It's learning how to analyze data and how to network with other people and build community. So all of that I think are strong elements of the program. Yes, Nebus. One of my cats wants to get back on top of the computer here.
Thank you very much, Marty. That was very helpful.
Yeah. So Dan asked if I could get bigger cats. Yeah.
Maybe be much bigger in South Africa.
Yeah. I probably don't really want a lion. I mean, I don't know exactly where one gonna live, but yeah. Although somebody was telling me it's make sure your cats stay inside because there are insects big enough to kill those cats in Africa. So yes, she will have to stay inside. I can't quite see if there are more chat messages.
There are a couple from Gong, Lou, and Sarah, not questions, and a few other people just saying, thanks for your contributions and best of luck in South Africa. Any other questions or comments?
One more thing, Marty. Obviously, probably the REU is a U.S. funded program for U.S. students. But any chance of sending over some SANSA undergrads some year back to Boulder to start?
Yes, I'm not sure of the finances for that as a possibility. I certainly have a budget to pay students to do research projects, and I think there has to be the opportunity to write proposals to get a grant to send students to foreign places. And yes, I think sending a student to Boulder would be the making of the person. They would get so much out of a program, the future REU. So yep, I have a vested interest in having it continue to be a success, right?
Alice, did you have a question or comment?
Yes, I was actually just going to ask the same thing that Scott just did, basically, and it would be really nice to have that larger pool of potential interns to come to Boulder, and so yeah, essentially the same thing that Scott just said. And also, Marty, I'm going to miss you, but it'll be great to still collaborate with you. So that'll be awesome.
Yeah. No, I imagine that you know, the Space Weather Workshop in Boulder will be a conference I can weasel my way into visiting, so I can come visit everyone here and give a talk about what's going on in South Africa, and I think that you know, they said that due to COVID they haven't had too many visitors in 2020, but they have a strong visitor program, so hopefully some of you will get to come visit South Africa.
I think one of our biggest challenges is having that collaboration with a broader field. So that'll be fantastic. Thank you.
Yeah. Oh, Sarah says, yeah, we should host an IAU symposium. I think that sounds like a great idea.
There's a lot of really great stuff going on also in just the different offices for development and education in IAU too. So you should get some good solar stuff in there.
Yeah, thanks.
Any final questions or comments? If not, thank you again. Oh, I think Phil has somebody.
Yeah. Marty, congratulations.
Thank you.
I remember those early days working with you on the GHRS data, which is fun. I just wanted to ask a couple of questions, which maybe you answered. I had to step out. So what advantages do you think you have being so far down in the southern hemisphere for things like space weather, you know, the access to, perhaps easier access to the Antarctic than most of us have, or things like this? And also, what kind of student populations are there within the universities across South Africa and neighboring countries which you can draw from? I mean, do you have a lot of physicists? Are there a lot of mathematicians? Are they all doing different things? But, you know, just an idea of the kind of pool of students you might have.
So, I don't know why my camera went away, but hopefully you can still hear me. So, one thing that a ground-based observations from South Africa, you know, you're at the same longitude as Europe, but your seasons are out of phase. So the weeks that, or the time of year when you know, you have bad weather is when Europe has good weather, so you get good observing, and vice versa, right? When it's winter in Europe, that's when it's the best observing from the southern hemisphere. So that's one advantage, and so I've talked to Alexi, you know, about you know, someday having a gong station in the southern hemisphere, or you know, other ground-based observations. You know, if we can do calcium observations, or just even sunspots, right? That gives you better weather out of phase with European weather. Yes, as you say, there's access to Antarctica. I think many of the research vessels leave from Cape Town, so that's you know, a flood of researchers coming through there. In terms of the student population, I don't know yet exactly the answer to your question. You know, South Africa is a population of about 60 million. So it's a pretty populous country. There are many universities. I know they have a lot of physics departments and astronomy. And so I'm imagining that that most of the students that I would recruit into studying the sun would be coming from astronomy or other space physics. my the person who's going to be my postdoc, he did a research project on the solar cycle modulation of cosmic rays. So there is sort of solar adjacent work already being done, but in terms of actual solar physics programs, there aren't any. The as everybody knows, the history of South Africa has a lot of complicated racial implications. So it's true that the white students, the minority, maybe 20% of the population, right? They have most of the economic wealth, and so they have many of the students in the universities are affluent white students, but that's not all of the students, right? There are many from other racial groups, and so part of what I said that I would stress is increasing the diversity of the students, getting into sciences there. So I plan on trying to recruit Black women and so on into these positions. So the short answer is, yeah, I don't know, because I haven't actually been there. But from my background research and so on, I know that there is a diverse population of students in these universities, and I hope to make opportunities available to them so that they can succeed in joining the scientific community.
Great. I feel sure you're probably one of the best people I can think of to go and address those issues. And I personally want to thank you for having spent time with me in the past, and I learned from you, same as it works both ways. And I want to really wish you all the success in the world in that endeavor. It's a wonderful thing to do for humanity as much as anything. Congratulations.
Well, thank you very much.
All right, if there's nothing else, I think we can conclude there. Thanks again for the nice talk, and best of luck in South Africa.
All right, great. Thanks, everyone. I'm waving, but my camera stopped.